Welcome to 3.7. The new thing in this unit is pretty straightforward, and it's just that the branches on an organic compound don't have to be more carbons. We've seen you can have methyl groups and ethyl groups and occasionally hydroxyl groups stuck onto a chain, and that changes the name. You could also, in a lot of cases, get attachments from the halogen family. So we're talking about the second from the right column of the periodic table that goes fluorine, chlorine, bromine, iodine, astatine. And the endings for those normally, if you have an F attached to you, you're called a fluoride. Cl attached to you makes you a chloride. Br makes you a bromide. I makes you an iodide. And At, if only you could find some, makes you an astatide. If you want to talk about all of those at once, and just say you have some halogen attached to you, then we call you a halide. I tend to say halide when I'm not thinking about it, even though halide makes a lot more sense. So either way, this means there's some kind of halogen attached to your carbon chain. And when these are attached to an organic compound, instead of a chlorine, we call this, organics have to have different names for everything, a chloro group. And a Br is a bromo group. You can have fluoro groups. I don't know if there's any iodo groups in here. And astato groups are ultra rare because astatine is so rare. So mostly I think you're going to see FCl and Br in our practice. So I'll show you how these names work, and I don't think what you see will surprise you very much. It's just like what we did with carbon branches. Here we have a chain, a bunch of carbons, and there's a chlorine stuck onto it. What do we start with? The primary chain. This is 1, 2, 3, 4, 5, 6 carbons. There's all single bonds, so we can call this hexane. There's no hydroxyl groups or anything, so we're not worried about changing the ending to hexanol. It really is hexane. And there is a chloro group on the second carbon, so we call this 2-chlorohexane. That's it. Let's run through some practice or put me on mute and see if you can do them yourself. These aren't bad. I think you probably get the idea already. 1, 2, 3, 4, 5, 6 carbons in a ring is a cyclohexane. So that's our primary. Here we get a minor issue with alphabetical order. These two things are bromo groups, which of course starts with B. The single carbon here is a methyl group, which starts with M, so we should mention the bromo groups first. So if we put them on carbons 1 and 3, we can call this 1, 3, I'm going to make a small mistake here, 1,3-bromo. See what's missing? There are 2 bromines, so guess what? Dibromo. Just like if there were 2 methyls, you'd say dimethyl. 1,3-dibromo. And there should be a dash in there. It'll drive me crazy if I don't fix it. 1,3-dibromo is what I'm going for here. 1,3-dibromo. And then we have our methyl group, which is on carbon number 4. I really did not leave myself enough space here, sorry. 1,3-dibromo 4-methyl cyclohexane. Could we have done better with the numbering? If we went counterclockwise, we'd still get 1,3-dibromo, but then we'd get 4, 5, 6 for the methyl group. That's no good. And we had to talk about the bromo first, so yes, we do want these to be 1 and 3. It's not like we can call this 1 and then go 2, 4 for the bromines. You have to put your low numbers as early as you can get them. So 1,3-dibromo 4-methyl cyclohexane seems to be the best we can manage there. Okay. Took me a long time. If you muted me, you're probably done by now. Here our primary is 1, 2, 3, 4, 5, 6, 7 carbons, which is heptane. We have bromo groups which start with B and fluoro groups which start with F. So the bromine goes first, and that's on carbon number 3. It's obviously worse if you count from the right. So we have 3 bromo. And on the second carbon, we have 2 fluoro groups. So 2, 2. I assume you're on top of the fluoro thing by now. 2,2-difluoroheptane. And the spelling of fluoro is a little weird. Let me magnify that. Fluoro is what you want. Don't write this. This is milled grain used in baking. This is a flammable, poisonous, corrosive gas that we're talking about for our branches. This is the chemical F. This is the thing in your kitchen. Don't get them confused. We'll ding ya. Or I will anyway. All right, what do we have here? Our primary looks to be that. 1, 2, 3, 4, 5, 6. This is a hexane. It has a bromo group and it has 2 methyl groups. B comes before M. So from the left, this is the 3rd carbon. If we count from the right, it's the 4th carbon. So we'll take the 3rd, please. 3 bromo. And then we get 4,4-dimethyl. You've seen that before. 4,4-dimethylhexane. Not too bad. Last one. Our primary, they switched to line structure, which is not that big a difference. 1, 2, 3, 4, 5, 6, 7 carbons in our primary makes this a heptane. These are both fluoro groups, so it's going to be a difluoro. Difluoroheptane, and they're on carbons 2 and 3. So 2, 3-difluoroheptane should do it for that one. Not too bad. Good.